Hello guys, welcome back to Math Zone African Motives. We are on our mathematics for grade 11. This is one of the most important topics that you're gonna have in our syllabus, working with the part of exponents. Actually, it's exponents and sets, but in this part, we shall be focusing on the exponents. So for the basics of our revision, we've got the laws that I want you to watch the videos that I've made on the mathematics for grade 10 so that you'll be able to revise back the exponents. How do you apply these laws and so forth? So I'm just gonna explain the laws as we are given, then work with questions that are particularly in our syllabus. Okay, so for the basics of these exponents, make sure that you watch the videos for mathematics grade 10 for the recap of your exponents. All right, so from our laws in this case, remember, if you're dealing with exponents, provided that you are multiplying the bases which are the same, we are going to add the exponents a to the exponent of m, multiply to a to the exponent of n. We are going to multiply. When you're multiplying like this, you're going to add the exponent, that is m plus n. So this is provided that you are working with the bases which are the same in that manner, provided maybe this is x to the exponent of 3, that is multiplying x to the exponent of 5. Okay, no matter the number of x's that we have here, what is important that you're multiplying the bases that are the same. So you're going to add the exponents in this case, which is 3 and 5. So this is going to be 3 plus 5, which is going to be x to the exponent of 8. What you are working with in this case is the base, which is the same. Okay, so you're going to add the powers, the exponents that you are given. So this will be x to the exponent of 8. So it's the same thing for your division. If you're dividing the bases that are the same, you're going to subtract the exponents. Then on the multiplication, if there's an exponent and there is another exponent, what simply means is that you can multiply the exponents together, which can be also in another way. You can have it, this is a to the exponent of n to the exponent of m. It's one and the same thing that we are referring to, all right? Then also here we've got a condition whereby two terms, okay, or maybe two numbers that we have in a bracket are being raised to a single exponent. It means every term is going to be raised to that exponent that you're given. So that's a to the exponent of m. AB to the exponent of m is going to be a to the exponent of m times b to the exponent of m. Every part is going to be affected by the exponent. This is mostly used in the simplification. I'm going to explain these in detail. I just want you to know your laws. Like I said, just watch the videos on mathematics grade 10 for the recap. But as we are revising, I'm going to elaborate on these laws. Also, if you're dividing, the exponent is going to affect every term that you are given on the division. Then also you're supposed to know your definitions of your laws of exponents. So I want you to work out each and every part. So when we are revising, I'm going to refer to these as we shall be revising. All right, so make sure that you just have a basic understanding of each and every part, and also do not forget, like I said, to watch the videos for the mathematics grade 10 on your revisions. All right, so I want us to check questions. How are they given, and how do we apply the laws that we are given in the simplification process that we're going to have in our syllabus? All right, so you shall be given questions that you shall be asked to simplify. All right, so questions definitely shall be on the simplification. All right, let me just try to reduce this a little bit. All right, so it shall be given the questions that are on the simplification. To simplify, let's say we are given, in this case, to simplify, I'm just going to list down the questions that we are given in terms of our exponents. Let's say we are given to simplify 5 times 2 to the exponent of x minus 2 to the exponent of x plus 2, like this. Okay. In terms of the simplification, it follows that whenever you're given this type of a question, you check, you're going to see that there is 2 to the exponent of x here, and there's also a possibility of having 2 to the exponent of x. So it follows that if we can have this in terms of 2 to the exponent of x on this part, and also another 2 to the exponent of x, we can be able to apply our factorization. Remember your basics of factorization from your grade 10. But I want you to see what is happening on 2 to the exponent of x plus 2. Okay, I want us to get to this law that we are having. We are given here a to the exponent of m plus n. What made us to add like this? It means previously we were multiplying the bases that are the same. So it's like a reverse of the laws that we are given, all right? We are adding here. So it simply means we are adding these exponents. So previously, it means we are multiplying the bases that are the same. All right, so this follows that we're going to have this as 5 multiplied by 2 to the exponent of x minus this part is the same as 2 to the exponent of x that is being multiplied to 2 to the exponent of 2, so that we add x plus 2 because the bases are the same if you're multiplying. So we are going to have this part. All right, but I want you to see that it is the same thing. Do not confuse this because I'm going to maintain the same thing even on a subtraction. You're going to see me multiplying like this, then you should be wondering why. Okay, let me explain this. Let's say this question was in the form of 5 times 2 to the exponent of x, which is minus 2 to the exponent of x minus 2 like this. It is true that on this stage, we were supposed to apply the division to say, okay, here I'm subtracting the exponents. So it means I was dividing. In the previous case, I was dividing the bases that are the same, a to the exponent of m and a to the exponent of n. I was dividing. But here, in this manner of writing this as 2 to the exponent of x over 2 to the exponent of 2 like this, right? I want you to see it is the same. This is exactly how you're supposed to write it. So that, okay, you say, I'm dividing the bases that are the same, so I'm going to subtract the exponents. But even if you are to write it in this manner, it is going to mean the same thing. I want you to see what's going to happen. Even if we write it in terms of a multiplication, it was going to be 5 times 2 to the exponent of x minus 2 to the exponent of x times 2 to the exponent of minus 2. All right, let's try to make sense out of this. We said, if we are multiplying the bases that are the same like this, we're going to add the exponents, which is true. So let us add the exponents and see. This is going to be 2 to the exponent of x plus the exponent that we are given here, which is a negative 2. So at the end, we are seeing that we've got a plus and a minus, which is going to give us 2 to the exponent of x minus 2. So which is the same as this part. So at the end, whether it's a subtraction, whether it's an addition, how to separate this? You're going to separate it by a multiplication. You simply multiply to the other part 2 to the exponent of the other part that you're given, 2 to the exponent of the other part that you're given. That is how you're going to separate this. Like I said, whether it's an addition or whether it's a subtraction, as we saw that on this part, we have proved that it's one and the same thing. Whether I'm dividing this way or I'm multiplying this way, I'm going to have the same answer. So that means I can expand this in either way. Okay, so here it was an addition. So we are going to focus on the part of an addition, which is this part here that we are having on this side. So on this part, this is what we have. We have managed to separate this to 2 to the exponent of x plus 2 as 2 to the exponent of x times 2 to the exponent of 2. What is it that we are seeing? We are seeing that there's a common term that is the 2 to the exponent of x. We've got 2 to the exponent of x here. We also have 2 to the exponent of x, which is common between these two terms. So when it is like that, you can be able to factor out that common term, which is the 2 to the exponent of x from your factorization. So in this case, you are going to factorize. I want you to see what is going to happen in this case. All right. We could have just simplified direct, but I want you to see, okay, I'm going to explain this later on. 2 to the exponent of x is common. So let's factor it out and see what's going to happen. I remove this 2 to the exponent of x, which means I'm going to remain with a 5. Okay, remember your factorization, guys, from your grade 10. We do the same thing. We factor out 2 to the exponent of x. We are going to remain with 2 to the exponent of 4. But take note, there is a negative that we have. So this is negative 2 to the exponent of 2, which is same as a 4. This part we could have not factorized, guys. This is a matter of like terms. I want you to see what is happening. 5 times 2 to the exponent of x minus 2 to the exponent of 2, that's a 4. 2 times 2, that's a 4. So it's the same as 4 to the x, 4 times 2 to the exponent of x like this. There is no need for us to factor out 2 to the exponent of x there. We are simply subtracting. These are like terms, as we can see here. We've got 2 to the exponent of x, 2 to the exponent of x. These are like terms. So this is the same thing as we've got 5x minus 4x, or maybe 5y minus 4y, or maybe this is 5m minus 4m. Just like that, we have got like terms. So we are simply subtracting 5 minus 4, which gives us a 1. So this is going to be 1 times 2 to the exponent of x, which is same as what? 2 to the exponent of x. But this is the same thing that we have here, because this is the most method that you have in your textbook. So you'll be wondering, what is it? But you are not even supposed to have any factorization, but this is what you can do. You can factorize, like I said, then you can simplify this. This is 2 to the exponent of x. All right, let's just write equal to, so times 5 minus 2 to the exponent of 4, 2 to the exponent of 2, which is a 1, right? So this is, you can simplify on your calculator, 2 to the exponent of 2, that's a 4. So that's 5 minus 4, which is a 1, or you can just simplify direct on your calculator. That's 5 minus 2 to the exponent of a 2 like this, which is going to give us a 1. So that's it. Any number times 1 remains as it is. So if you multiply 2 to the exponent of x times 1, it is going to remain as it is, as 2 to the exponent of what? As 2 to the exponent of x. So this is how we could have simplified this type of a question. These are the questions that you expect to have in our syllabus, okay? But like I said, make sure that you revise your basics from your mathematics grade 10 so that you can be able to equip yourself, but mostly on your syllabus, this is what you're going to have. All right, let us have another question. Let's say again, we are asked to simplify 9 to the exponent of x plus 3 to the exponent of 2x plus 1. Okay, on the previous question that we had, it was a direct part that we can properly see that 2 is directly common. You can see the 2 that is common. But here we are not seeing that. This is a 9, this is a 3. So what you do in that case, you have to write your numbers in simplest form. All right, there's nothing that I can do to 3. 3 is already in simplest form. 3 is a prime number. It's only divisible by 1 and itself. But 9 is not in simplest form. So meaning to say I'm supposed to simplify this 9 as a number in simplest form, that is as a product of its prime factors. Remember, 9 as a product of its prime factors is same as what? 3 times 3, which is same as 3 squared. If a number is multiplying itself, it's the same as that number to the exponent, the number of times it is multiplying itself. So it's 3 times 3, which is 3 squared. So if 9 is the same as 3 squared, what does it mean? It means that in place of this 9, we can write this as 3 squared. So we're going to write this in place of 9 as 3 to the exponent of 2. That is in place of 9. But this whole part is being raised to the exponent of x, all right? Plus 3 to the exponent. Remember the part that I explained before about this addition concept of the exponents. How do you separate this? So it means we've got 3 to the exponent of 2x, which was multiplying just like this part, 2 to the exponent of 2. So here we are multiplying 3 to the exponent of what? 3 to the exponent of a 1. Okay, there is a law that we are having here. That is where our laws now are playing a part. But like I said, in our syllabus, we're not gonna like consider the basics. Okay, these are the questions. So now we are back to the condition of an exponent versus an exponent. So this is the concept here, a to the exponent of m to the exponent of n. We said we're gonna multiply the exponents together. So meaning to say on this part, we are going to multiply these exponents 2 times x, which is going to be 3 to the exponent of 2x, that is 2 times x, which is what? 2x, plus 3 to the exponent of 2x times 3 to the exponent of 1 is same as what? Is same as 3. So we are back to that situation or that scenario that I was explaining before, to say there was no need for us to factorize, because we can see that here there's a 1. So I can simply add 1 plus 3, I get a 4. I can simply have the answer as 4 times 3 to the exponent of x. 3 to the exponent of what? Of 2x, I mean. But because of this thing of that we have in our syllabus, our question papers, in our revisions, you end up like it's a uniform thing, but it's not. Okay, anyways, this is it, guys, so that we do not confuse each other. So this is what you see. we can see that we've got 3 to the exponent of 2x here, which is the same as the 3 to the exponent of 2x that we also have on this term. They are the same. So we can factor it out, but knowing that here is the same as there is a 1. So the moment I factor out the 3 to the exponent of 2x, which is common, that means here I'm going to remain with a 1. I factor out this, I remain with a 1, plus if I factor out 3 to the exponent of 2x, I'm going to remain with what? I'm going to remain with a 3. So this is what I'm going to have at the end. So we can be able to simplify this. That's 1 plus 3, which is going to give us a 4. So that's 3 to the exponent of 2x times a 4. And this is same as 4 times 3 to the exponent of 2x, like this. Remember that a times b is the same as b times a. So if I multiply 3 to the exponent of 2x times 4, it is the same thing as 4 times 3 to the exponent of what? Of 2x. So this is our final answer. This is how you can have our final answer as. So these are the questions that you're going to be asked on the simplification. As long you are to simplify, that is how they will ask these questions. All right, let's take another question. Let's say we are asked to simplify 2 times 10 to the exponent of x minus 5 to the exponent of x plus 1 times 2 to the exponent of x. We're asked to simplify this. So sometimes they can even ask you to show that this is going to be simplified to as. All right. So I want us to see something here. If this question, all right, so this one, I want us to have it as show that. Show that. Okay, let me write the show that here. Show that. Okay, I'm writing two things at the same time. All right, show that this part that we have reduces to or is equal to negative 3 times 10 to the exponent of x. All right, I want us to work with this question like a proof, like a show that type of a question. Okay, they gave us this question to say show that it is going to give us this. It is a same thing like a simplification. To show that or to simplify normally is the same. All right. To simplify or to show that is the same. So what am I trying to say? When you're asked to show, like you're asked to show that it is going to, you have an answer there. So your answer is supposed to be exactly the same the way that you're given. Whereas for a simplify, you can write your answer in another way, which can be the same way as the other way that can be given, but in a different presentation. So this one, we want to have it like show that our answer is like this. So as we are given that your answer is going to be given as the negative 3 times 10 to the exponent of x, it means we are supposed to have our answers in terms of 10, like you can see 10 to the exponent of x. So here there's nothing that I can do on the first part because already I'm having what? I'm having the 10 to the exponent of x. It's already there, all right? So this is going to be 2 times 10 to the exponent of x minus, okay, we are back to that part of our simplification. 5 to the exponent of x plus 1. How do we separate this? It is going to give us 5 to the exponent of x times 5 to the exponent of 1. All right, remember how you separate your exponents. We are adding or subtracting. You multiply by that exponent as it is. All right, but there is also a 2 to the exponent of x, which is there. So you're going to multiply by 2 to the exponent of x as it is. So the question that you must be wondering is that how can we obtain 10 to the exponent of x from these numbers that we have here? I want us to get back to this law here. Okay, I want us to get back here. AB to the exponent of m means a to the exponent of m, b to the exponent of m. So it means if the exponent is the same, I can rewrite these two numbers multiplying together with the same exponent. And this is exactly what we are having here. The 5 and the 2 here, both are raised to the same exponent of x. So it means I can rewrite these two numbers as 2 times 10 to the exponent of x minus 5 times 2 everything to the exponent of x, which is the common exponent between these two. This does not affect this. 5 to the exponent of 1. 5 to the exponent of 1 is not affected at all. It just remains as it is. 5 to the exponent of 1, which is just them as what? As a 5. So this one is a reverse. We know that if we are given 5 times 2 to the exponent of x like this, how do we simplify this? We raise everything to the exponent of x. So this will be 5 to the exponent of x times 2 to the exponent of x. So this is what we have here previously. So it's a reverse that we are having. How was it given before as? Once we can do that, we can be able to simplify. And the reason of us combining the 5 and 2 is for us to obtain the 10, because we can see that on our final answer, it's written in terms of 10. So we are supposed to have 10 on our final answer. That's why we are supposed to multiply these. Okay, so this will be 5 times 2, which is a 10. So this will be 2 times 10 to the exponent of x minus, or we multiply this. All right, so you can even take this 5. It does not even affect. You can just write 5 times. Okay, 5 times 2 here, that's 10. So that's 10 to the exponent of x. We can combine these, okay? A, B, these are letters. It does not mean that if they are numbers, you just write them as 2 times 3. No, 2 times 3 is 6. A times B, we cannot combine it to be just a single number. But as it is, it's a single term. So if you are given 2 times 3, you can combine it, okay? Just like this part, 5 times 2, you can combine, you get what? A 10. So at this stage, you are back to that scenario or the situation of having these two to be the same. 10 to the exponent of x and 10 to the exponent of x are the same. So what are we going to do? We are going to factor out that 10 to the exponent of x, which is common. We remain with 2 on this part, and here we remain with minus 5. So let's subtract 2 minus 5, that's minus 3. So you're going to have minus 3 times 10 to the exponent of x, which is exactly what we are given to show in this case. This part that we have is exactly what we have, minus 3 times 10 to the exponent of what? Times 10 to the exponent of x. So these are the questions that you might be given basically in your syllabus. They just want you to test yourself on this simplification. So it can also be even under a division. As long you are applying the laws, they want you to apply each and every law. All right, let's say we've got a division. Let's just say we've got a division of exponents. So we've got division of exponents in this case. Okay. Again, it is on the simplification. The question will be asking, you will be asked to simplify. Again, you are asked to simplify. And you have got, in this case, all right, so let us consider 10 to the exponent of x times 25 to the exponent of x plus 1, everything over 5 to the exponent of x times 50 to the exponent of x minus 1, like this. Okay, we are still on the simplification, but this type of a question is a tricky question that you need to analyze. Okay, how are we going to analyze this question? How are we going to analyze this? In which manner, or how are we going to simplify this? That is the question. Okay, I want you to see something here. The bases are totally different. There is a 10 here, there's a 25, there's a 5, there's a 50. All right. In a manner or in a situation like this, where the bases are totally different, try by all means to write your numbers in simplest form. All right. Expand the given numbers. All right. Expand the given numbers in simplest form. That is in a simplest form, all right, which are actually in simplest prime form, in simplest prime factors. That is the way that we can have this. All right. Why considering a prime factor? Because a prime factor is the simplest number because it's only divisible by 1 and itself. 3 is a prime number. There is only 1 and 3 there. 2 is a prime number. There's only 1 and 2. 5 is a prime number, 7 is a prime number. These are the prime number. So if our numbers are written as prime numbers, we are very sure that there is no other factor that can be found within that number. We are very certain there is no other term. Guys, let's write this. Let's have 11. 11 is the simplest number on earth, because I know that there is no other factor. There is no 2, there is no 3, there is no other factor. Let's talk about 2. It is the simplest number on earth. Again, there is no other factor. It's just 2 and 1. These are the numbers that you're considering. Just 2 and a 1. So these numbers, which are prime numbers, are the simplest numbers that we can have that can be used in our simplification. We are so certain, we are so much certain that our numbers are in simplest form. That's what I'm trying to say. Okay, so let's try that and see. Let's start with 10. 10 as a number that is expressed in simplest prime factors. 10 is same as what? 2 times 5. These are the only numbers that we have in 10. 2 a prime number and 5 also a prime number. So 10 can be written as what? As 2 times 5. So 10 is just direct. So this is equal to 2 times 5, but everything is being raised to the exponent of x. Okay, let's move on to 25. 25 can be expressed as 5 times 5. These are the prime numbers that we have. 5 times 5, which is 5 times 5 is same as what? 5 squared. So in place of 25, we can have this as 5 to the exponent of 2. But considering that there is also another exponent that is already given, which is of x plus what? X plus 1. All right. Let's move on to another part. We've got 5 already. 5 is a prime number. There's only 1 and 5 in 5. So that is, it's already in the simplest form. 50. So we're going to multiply 50. Let's check. But if we check here, we are already having a 25. So to have a 50, it means we just have to multiply by 2. Meaning to say here, we just have to multiply by 2. Here, we just have to multiply by 2, because 50 is 25 times 2, guys. And already we've got 25 as 5 squared. So we are simply going to multiply that by 2. So 50 is same as 2 times 5 squared. But everything has to be raised to the exponent of x minus 1. All right. So if we check, if these numbers are in simplest prime factors like this, it allows us to have even, so we can even able to notice the same basis. So here we are back to that law. Whenever there's an exponent, right? 2 times 5 to the exponent of x, we are back to this law. A times b to the exponent of m, every term is going to be raised to the exponent of what? M. That is a to the exponent of m, b to the exponent of m. So this is what we are having on this part of 2 times 5 to the exponent of x. So that will be 2 to the exponent of x. All right. 5 also raised to the exponent of x. Okay. Then on this part, we are having an exponent versus an exponent. So what is the concept? We multiply the exponents together. That is a to the exponent of m to the exponent of n. We multiply the exponents m times n under the same base. So this is what is going to happen. Under the same base of 5, but we are going to multiply these exponents. So this will be 5 to the exponent of 2 times x, which is 2x, 2 times 2, which is going to give us what? A 2. So we have got 5 to the exponent of 2x plus 2. All right, everything over here, we're going to have 5 to the exponent of x, which is already in simplest form. Then on this part, we are back to the distributing part of this raised to a certain exponent, where everything is going to be raised to that exponent. So if we check properly, 2 was supposed to be raised to the exponent of x minus 1 like that. So it is supposed to be like this. 2 to the exponent of x minus 1 times the 5 to the exponent of 2 being raised to the exponent of x minus 1. So it is supposed to be 5 to the exponent of 2, but to the exponent of, again, x minus 1. So we are back to this concept of an exponent and an exponent, where we have to multiply everything by what? By the given term, that is the exponent. So this is going to be 2 to the exponent of x minus 1 times, let's multiply 2 times x, that is going to be 5 to the exponent of 2x, 2 times negative 1, which is a negative 2. So at this stage, if you are to consider properly, you can see that there's no need, guys. Yes, you can expand, it's up to you. But here I can see that there's something that is common. The 2 to the exponent, the base of 2, I can consider that base alone to say this base here, I can work with this. Okay, but before that, there is something that was just here. I guess now we are in grade 11, we are not grade 10s, okay? Some of these questions, if you can see it, guys, consider that part and use it as of advantage. You can see that 5 to the exponent of x is the same as this. Cancel those things. They are the same. There's no need for you to keep this. The numerator denominator concept, we must understand this, okay? So you can cancel this part out. Okay, so let's get back to my my explanation here. I was saying this part and this part, we have got the same bases and we are dividing. So we said when we are dividing the bases that are the same, what is it that we are supposed to do? We are supposed to subtract the exponents because the bases are the same and we are dividing. So there we are supposed to subtract the exponents in the base of 2. In the base of 2. So this will be 2 to the exponent of what? Already on top, this is x. So we are going to subtract this exponent. So it's going to be minus x minus 1 like this. Okay, the same thing. There is a 5 on top here that we are given, a 5 to the exponent of 2x plus 2 that we are given on top. And there is a 5 to the exponent of 2x minus 2 that we are given in the base. All right, these ones, we cancel them. This part here, we cancel because it's the same. These ones are not the same. This is 2x plus 2. This is 2x minus 2. They are not the same, but the bases are the same. So considering that the bases are the same, this is what we want. We are going to subtract the exponents since we are dividing. So that will be 5 to the exponent of 2x plus 2. Subtract the exponent, the other exponent that we have in the denominator, which is 2x minus 2 like this. Okay. So this means that we can be able to simplify. Now it's interesting when it is like this, guys, because it's just a matter of you expanding of the brackets, collecting of like terms, and so forth and so forth. So that is it on top. So this is 2 to the exponent of x minus times x. That will be minus x minus multiplies x multiplies minus 1. So that's minus and minus, which is going to be a positive 1. Okay, times 5 to the exponent of, this is going to be already, we've got 2x plus 2. Then the minus is going to multiply 2x. Also, it is going to multiply the negative 2. So that's it, negative times 2x, which is going to be negative 2x, negative times a negative 2, which is going to be a positive 2. So we are considering negative 2 and negative. That will be a positive. So at that stage, we can be able to simplify here. That's x minus x is same as 1x minus 1x, guys. This cancels, to remain with a 1. So that's 2 to the exponent of 1 times, we do the same thing, 2x minus 2x, 2 minus 2, that's a 0, guys, cancels. Then we are left with 2 plus 2. So these two, they add 2 plus 2, that's a 4, but it is operated under the base of 5. So it is going to be 5 to the exponent of 2 plus 2, which is a 4. At this stage, yes, you can simplify 1, 1, this one, 2 to the exponent of 1, it's a 2, this and that. But here, you can just simplify this straight on your calculator to obtain the final answer. That is just 1 mark for that. Okay, so let us just say for a calculator here, that is going to be 2 to the exponent of 1. 2 to the exponent of 1, guys, it's a 2, all right? It's same as a 2, okay? Times 5 to the exponent of a 4, which is 1,250. So this is going to give us 1,250. So this is the answer that you're supposed to obtain after simplifying this whole part. So make sure, guys, you work these questions perfectly, all right? Do not rush. make sure that you simplify each and every stage that you are given step by step by writing, like I said, expand the given numbers. If possible, this is the way that you're supposed to have, write them in simplest prime factors, as simplest prime factors. Once they are written as prime factors, there is no way you can be able, there is no way that person is going to give you a challenge. There is no way, as long they are prime factors, prime numbers. So make sure each number is written as product of its prime factors. Then you can simplify applying the laws of your exponents. All right, let's see this one here. Let's see this one. Another question. Let's say we are given 6 to the exponent of x times 9 to the exponent of x plus 1 times a 2, like this. Okay. Everything over 27 to the exponent of x plus 1 times 2 to the exponent of x minus 1. Let's say this is what we're given. Okay. So under this simplification, what can we do from this one? Okay, if we are to check properly here, this is what we have. Again, like I said, in simplest form. So you just have to ask yourself, in simplest prime factors, okay? 6 as a product of these prime factors, 6 is simply 2 times 3, right? So that is what we have on 6. That's just 2 times 3. So this is going to be 2 times 3, but everything is being raised to the exponent of what? To the exponent of x, okay, times 9 is same as 3 times 3. We talked about this, which gave us 3 squared, okay? So this is going to give us 3 to the exponent of 2. But there is already an exponent which is there, which is x plus 1. We are already given an exponent there, which is x plus 1. So you're going to have this, then 2. Is there anything that we can do on 2? Nothing, is already in simplest form. So this is just a 2. All right. Now let's move on to the other part. Everything here is divided by 27. If you're someone who understands the issue of the cube root, that is working with perfect cubes, you can tell something about 27. This is simply what? 3 to the exponent of 3. All right, that's 3 times 3 times 3. 3 times 3, which is 9. 9 times 3, which is 27. So meaning to say, in place of 27, we can have this as 3 to the exponent of 3. That is in simplest form. But there is an exponent already that we are given, which is x plus 1. So it's going to be x plus 1, like this, times 2 to the exponent of x minus 1 is already in simplest form. There's nothing that we can do on this part, guys. Okay, now we are back to that part that we can apply our laws, as long there are laws that can be applied in terms of these exponents, like this part. 2 terms being multiplied, we said each and every number is going to be raised to the exponent of x. So that means here we are going to have 2 to the exponent of x times 3 to the exponent of x, okay, every term. Then on this part, we are going to multiply because there's an exponent and another exponent. So we multiply everything. So 2 is going to distribute everything. So this will be 3 to the exponent of 2 times x, which is 2x, like that. Then 2 times 1, which is going to be a 2, all right? On 2, there's nothing that we can do. Maybe you can just write as 2 to the exponent of 1. Just write also in terms of exponents, all right? Just 2 to the exponent of 1, 2 to the exponent of a 1. Then let's consider our denominator in this case. In our denominator, we have the same thing. The 3 is going to distribute again throughout. So this will be 3 to the exponent of 3x, 3 times 1, which is going to give us a 3, times 2 to the exponent of x minus 1. Okay, so this is where we are now. This is where we are. On a consideration that we want to cancel this and that is fine, but it can be too late for us to do that. It can be too late for us to apply that grade 10 part that we used to do. It can be too late. So what are we going to do? This is it. We are going to just apply our laws direct, because as long the bases are the same, we know that we can apply the laws. So on the multiplication, I want us to consider what we have on the numerator here. All right. in terms of the base of 2. All right, let's consider the base of 2, right? I'm consider the base of 2. This is 2 to the exponent of x here. There's a 2 to the exponent of 1 here. There's another 2 to the exponent of x minus 1 that is in the denominator. But in the numerator on top, here on top, everything is under a multiplication. And we know that if the bases are the same and we are multiplying, we are supposed to be adding the exponents in this case. All right, we are supposed to be adding the exponents. So this is what you're going to do on the numerator. On the numerator, because we are multiplying the bases that are the same, we are considering the base of 2. We are going to add the exponents. So it is going to be 2 to the exponent of x plus a 1. But this part, after combining, we can see that there is a 2 to the exponent of x minus 1 that is in the denominator, that is dividing. So what do we do with this one? We subtract that one. We are dividing this term. So we are going to subtract x minus 1 like this. Okay, we are done on 2. We move on to 3, okay, times. Let us consider the part where there is 3. So there is 3 here, 3 to the exponent of x. There is 3 to the exponent of 2x here plus 2. There is 3 to the exponent of 2x of 3x plus 3 like this. So from the numerator, if you are to consider this, from the numerator here, these two are multiplied. So we are going to add them in the numerator, 3 to the exponent of x plus this exponent, which is we are going to add 2x plus what? Plus 2. But whatever that we get, because there is another 3 that we see in the denominator here, which is dividing. And if we are dividing, we know that we subtract the exponent. And whatever that you subtract, you open a bracket for that. So we are going to open the bracket for 3x plus 3. That is this 3x plus 3 that is under the base of 3. So we have simplified everything that has got to do with the 2, everything that has got to do with the 3. So we can simplify this in simplest form. That will be 2 to the exponent of, let's simplify, this is going to be x plus 1 minus times x here is going to give us minus x minus times minus, that is going to be a plus. So it's going to be plus 1. So we have got x minus x, which is a 0 there. This is same as 1x minus 1x. So we're left with 1 plus 1, which is a 2. So that's 2 to the exponent of 2. All right, we do the same thing. We simplify here, x plus 2x. This is going to give us 3x plus this 2 here. All right, then we expand by the negative throughout. So this will be negative times 3x, which is negative 3x, negative times this 3, which is going to be a negative 3. 3x minus 3x, that's a 0. 2 minus 3, 2 minus 3, that's a minus 1. So it means we are left with the 3 to the exponent of a negative 1. Okay? Yes, we can multiply, guys. We know that 2 to the exponent of 2, that's a 4. 2 times 2, that's a 4. So this is going to give us 4 times. What about 3 to the exponent of 1? Remember, any number to the exponent of a negative can be taken the negative as 1 over. We are back to this law. X to the exponent of negative n is 1 over x to the exponent of n. So meaning to say, wherever we have a negative exponent like this, we can remove this as 1 over. So this is 1 over 3 to the exponent of 1, of which 3 to the exponent of 1 is same as 3. So we can multiply. Remember, 4 as a whole number is same as 4 over 1. So you can multiply 4 times 1, which is 4 over 1 times 3, which is a 3. All right, but I always say at a simple stage, if you are given, if you're at this stage, there is no mark that you're gonna have for any working that you're gonna show there. The last answer, the last mark is for the answer. So just use a calculator from that stage. All right, just simplify direct here on your calculator. This is going to be 2 to the exponent of 2 times 3 to the exponent of a negative 1. Direct like this on your calculator, you're going to get 4 over 3. Simplify like that, you have your answer. So there's no mark that you're going to get for any other process or any other calculation that you're going to have here. All right, so we shall have a follow-up exercise on this part that we had on the simplification of the exponents. There are a lot of things that we're going to consider. Like I said, the idea of these exponents is a whole lot of things that you need to understand in your syllabus, but make sure that you also revise from a grade 10 exponents as a recap, then work on these exponents which are part of our syllabus, okay? We are now working with what our syllabus requires, not those basics that we had to work with in our grade 10. Those were basics of your exponents. Now you are into detail of the exponents. So make sure that you understand the basics first, so that whenever you're simplifying, you can be able to tell that your answer is in simplest form or not. You cannot see that your answer is not in simplest form because you do not understand your laws. If you do not understand your laws, you can even leave your answer as 3 to the exponent of -1. Why? Because you do not understand that this can be written further as 1/3. So make sure you understand, you go through each and every law and also the definitions of your exponents in that case, all right? From your laws to the definitions, make sure that you go through each and every part that you're given, all the laws that you're given, apply them. Each and every law is used. All the definitions here that we have, they are applicable one way or the other. You're going to see where it is required, where it needs us to apply these. It's only a matter of that we haven't done any question that had to apply a certain law or a certain rule or a certain definition. But make sure revise all of them, understand all your laws, because one way or the other, there is a question that is going to come up across one of these laws. So it is best that you revise all of them so that if a question is asked along a certain law, you can be able to answer that question because you know all your laws. All right, so like I said, we shall have a follow-up exercise in our next class.